Now let's look at actually doing the hypothesis test. So first hypothesis test for mean mu, and then later we look at hypothesis testing for population proportion pi. Now we're going to look at two cases. One is sigma is known, the other is sigma is unknown. Similar to chapter 8 in confidence interval, where we first looked at a case where sigma is known, where we used z, and then when sigma is unknown we used t. Same here, when sigma is known we will use a z test, sigma is unknown we will use a t test. Now sigma being known is not common. It's very unusual, but sometimes you may have it, you may have the value available. And also the formula that we develop for sigma is known is what is then transformed into a formula when sigma is unknown. So you can think of this as the first step to then move to a more practical and more common case of sigma unknown t test. Okay, first is z test, and both for z and t test we can look at hypothesis testing as two different ways in which to do the hypothesis testing. One is the critical value approach, and the other is p-value approach. So I'll demonstrate both of them, and you should master both approaches. So z is known, then you compute a z statistic, test statistic, okay, using this formula x bar minus mu over sigma over square root of n. So you're now taking x bar and converting that x bar into a z score. Remember z score from way back, where z score for x is x minus mu over sigma. Now here, since we have x bar and not x, so you divide x bar minus mu by the standard error of x bar, then you get a z score, and that is z stat. Now if the z stat is far enough, okay, so now we have to establish a critical value for the z stat. Now if the z stat value falls outside the critical value, and that critical value will depend upon the level of confidence or the significance level, the probability of type 1 error that you're willing to tolerate, that's your alpha. So for a given alpha you find the z table value, and that would be your critical value. So if your z stat falls outside the table value, then it is far enough from the mean that you are willing to take a stand and then say reject the null hypothesis. But if it is not, if it is below, inside the critical value, then you cannot take a stand. Then you can say, I'm not going to reject the null hypothesis. Do not reject null hypothesis is what you would conclude. Okay, so we'll start with a two-tailed test, meaning mu equal to some value, mu not equal to some value. So rejection can happen on either side of the normal distribution. That's why it's called a two-tailed test. So convert x bar into a z stat, find z critical value, and then you reject the null hypothesis. That's your decision rule if z stat falls outside the critical value, otherwise do not reject. So here mu is 30, mu not equal to 30. So the lower critical value and upper critical value, if alpha is 5%, then this is 2.5%, this is 2.5%. Here you'll have 1.96 and 1.96. Okay, and here are the steps that you can use for critical value approach. So suppose that alpha is 0.05, n is 100 for this test, okay, and sigma is assumed to be known, okay. So n is 100, x bar is 29.84, sigma is 0.8 given, then you plug in the values and you get a z stat of minus 2. So your critical value for z is plus or minus 1.96. So your z stat falls outside the critical value, then you reject the null hypothesis because the z score is far enough from the central value. Then you can say that we have sufficient evidence to conclude that the mean is not 30. Okay, and the probability that we are making a mistake is no greater than 5%. Now, on the other hand, we can actually calculate what the probability of type 1 error is going to be, the actual probability. So that's the p-value. P-value is the actual probability of committing type 1 error. Then if that probability is within the threshold of alpha, okay, and then that is a low enough probability for us to take a stand and then say we reject the null hypothesis. If the p-value is greater than alpha, then there's too high a risk involved in taking a stand. So you say mute and then say I'm not going to reject the null hypothesis. That's your p-value approach. Okay, so that's what I just stated is stated here. And how to compute the p-value? Okay, so that you compute the probability when mu is 30 and you find the z stat value, and for that z stat of minus 2, then you look up the probability. Okay, it's a two-tail test. You have to look at that tail as well as that tail. So you have minus 2 is the calculated z value, and for that calculated z value, the tail area from the normal distribution table is 0.0228. So now, since this is a two-tail test, you have a similar tail on the other side. So add the two and you get 0.0456, and that's the actual probability of committing type 1 error. And since this probability is less than 5%, 0.05, then this probability is a small enough probability for us to take a stand and reject the null hypothesis that mean mu is 30. And then we can interpret this as that rejection, the probability of we making a mistake, we having made a mistake of rejecting the null hypothesis actually true, is 0.0456.